in the last class, what we have done is we have found the equation for resistivity, conductivity, and so on. So in today's class, what we will do is we will find work done by a charge. Okay. So why are we finding work done is to calculate the power, and power is what we use in our household and all those things. So for that, first of all, we need to find the work done. Here's one circuit. Batteries are connected to a box over here. This box can be anything like your resistance, your bulb, or anything which consumes power. So this is positive terminal, this side is negative. So A is at higher potential, B is at lower potential. So when a charge flows, it flows from higher potential to lower potential. So it flows from A to B. The charge flows from A to B. Now V is the potential difference between A and B. If there is a potential difference, then only the charge will be able to flow. If there is no difference in the potential, then the charge will not be able to flow. You have to know that. So charge flows from A to B. Now you have to find the work done. First of all, you have to find what is charge. The amount of charge which flows through the wire is given by equation Q. That is I into T. This you already know. I is current, T is time. This I have written from the equation, that is I is equals to Q by T. Current is charge per time. So just rearranging the equation, Q is I into T. This is the equation of charge. Now next, what you have to do is you have to find the work done. Equation for work done. Now from this equation, that is potential is work done per charge. It will be your work done. Work done is potential into charge. This will be your work done. Now if you put the value of Q over here, what we get is, if you put the value of Q over here, in place of Q we are writing IT, it will be VIT. This is one equation for work done. If you know the potential, if you know the amount of current and for how long it has been moving around, that is the time, then we can calculate the work done. Okay. Now another equation for work done. We know that V is IT, and from Ohm's law, V is equal to I into R. There is also another equation, V is equal to I into R. Now what is R? R is the resistance. Suppose in this box over here we keep a resistance, then we can find the value. If the value of resistance is given, and still we can find the work done. So if you put V is equal to IR in this equation or this equation, you can find W. So in this equation we are writing, in place of V we are writing IR. IT. So this is I square RT. Second equation for work done. Okay, this is the second one for work done. Now from the Ohm's law itself, if V is equal to IR, your I is equal to V by R. Now in place of I, if you write V by R, then what will be this equation of work done? In place of this I, we are writing V by R. So in place of I, we are writing V by R. So you can write it. Okay, so this R and this R, one R will get cancelled. So what we get is V square by R into T. This is the true equation for work done. So first equation is W is equal to VIT. If you know the potential, current and time, you can find the work done. In the second one, current, resistance and time. So you can find the work done. And the third one is potential divided by resistance into time. If you have these three quantities, there are three different equations depending upon the three different situations to find the work done by a charge when it moves from point A to point B. Now from the work done, what are we going to find is power. Before finding power, I'll tell you the unit of work done. Now unit of work done will be, unit is joule, okay? Unit of work done is joule. Remember that. Now next we will find power. Now what is power? Power is defined as work done per time. How much work is done by the charge per time. So power is equal to work done per time. Now if we have the three equations, different formulas for work done, similarly we will have three different formulas for power. So from the first equation, okay, from the first one, from equation 1, power is equal to work done per time, but we write in place of work done VIT divided by T. So T gets cancelled, power is V into I. Okay, this is one equation of work done. Alright, equation number 4. Another from equation 2. From equation 2, work done is I square RT divided by T. T gets cancelled, so this becomes I squared R. This is equation number 5. Now from equation 3, power is equal to work done is V square T by R divided by T. So T gets cancelled, which is V square by R, equation number 6. So from the 3 equations of work done, we have found out the 3 equations of power. So using these 3 equations, you can find the value of power if you know the work done and time. Now the units of power. There are different units of power, so that we'll study in detail. The unit of power is watt, but if the work done is higher, then watt will be very small, so we have to use higher unit for that. Okay? So, first, unit of power. And the unit of power is watt. Okay? Now, watt will be a very small unit if you are measuring the power consumed in our household, in by the bigger machineries and all. So, for that, what we do is we use kilowatt. So 1 kilowatt is equal to 1000 watt. Okay, 1 kilowatt is equal to 1000 watt. Or in mechanics, we use a term that is horsepower. So 1 horsepower is equal to 726 watt. Okay, remember this. It will be used very much useful in while doing numericals and all. So 1 horsepower is 746 watt. Now, we'll study about the energy consumption or commercial units of energy. So we know that unit of energy is also joule, because energy and work done are being compared to be the same thing. But in commercial unit, joule will be a very small unit. Okay? So commercial unit. Now whatever power is consumed in our house, we don't calculate that in terms of power, we calculate that in terms of energy. So your energy is, now from the relation, power is work done for time, you know that. And we also calculate work done, or we also assume work done to be the energy. So if work done is your energy, then from this equation, energy is power into time. So energy will be power consumed in certain amount of time. Now the unit of energy, commercial unit of energy. Unit of power is what? Time is second. That will be your energy part. Now in our household there are different ways of calculating unit. So that is BTU. That is board trade unit. This is one unit for energy. Another one is this board trade unit. This other one is unit, and other one is kilowatt hour. We know that is watt into second, but watt into second will be very small, so we use kilowatt hour. In simplicity, 1 unit is equal to 1 kilowatt into 1 hour. Okay, 1 unit means, now in simple language, 1 unit of energy means 1 kilowatt of power is being supplied by the main circuit, and that 1 unit of 1 kilowatt is being used continuously for 1 hour. Okay, that means the energy consumed will be 1 unit. So, one kilowatt into hour is equals to, in 1 kilowatt, how many watts are there? It is 1000 watts. And in 1 hour, how many seconds are there? 300, 2600 seconds. So this becomes, so in 1 kilowatt hour, it is 3.6 into 10 to the power 6 watt into second. These relations are required for conversions. Okay. So 1 kilowatt hour is also equals to 1 unit. 1 unit is equals to 1 kilowatt hour, which is equals to 3.6 into 10 to the power 6 watt second. Okay? This is commercial area. Now I will discuss about resistance. Resistance I have already discussed in the last class. Resistance and everything I have discussed. But in an appliance, resistance is given by this kind of box or a small tube kind of a thing made up of carbon is there. In that tube, we have got colors. Okay, 1, 2, 3 color, and 1 over here, that is 4 color. There are 4 colors in a resistance. So from the color itself, we can find out the value of that resistance, which is also known as color coding. Color coding of a resistance. Now we'll learn how to find out the value of a resistance by the given color. When the value of the resistance will not be given written in the resistance itself, but from the color we have to find out the resistance. Now there are 10 different types of colors. So from that color we have to find out the different resistance. Okay. Now there is one line from where we can remember or memorize the color. That is a red color over here. The value of A and B over here. Value of C is also known as multiplier. And D is the tolerance. I'll tell you about that. Now first let us discuss about the color. To remember the color, we write it this way. B.B. Roy of Great Britain visited Gateway of India. Okay? Remember this way. B.B. Roy of Great Britain visited Gateway of India. This way you remember the sequence of the color. Now this color will be, first one is black, second one is brown, R is for red, O is for orange, Y is for yellow, G is for green, P again is for blue, V is for violet, G is for grey, and W is for white. So this way you remember the color. There are 3 V's, don't get confused. It is black, brown and blue. G will be green and green. Now the values. The value of AB will be 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now the multipliers. Multipliers will be 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4, 10 to the power 5, 10 to the power 6, this will be 7, and 10 to the power 9. This will be the multipliers. Now D. D is for tolerance. D is for tolerance. There are 3 colors for tolerance. First one is gold. It will be 5% tolerance. Silver is 10%. And third one will be, if it doesn't have any color, that is no color, will be 20% tolerant. Okay, this way you can find the value. I will give you also one example also. Suppose in the question there is a sequence of color like the sequence of the color is red, orange, blue and silver. Okay, this is a random example. The sequence of color is given like this. So this is with your A, orange is B, this is C and this is D. Now from here we can find the value. Red, from your red is 2. Orange is 3. So this 2 will be the number, okay, initial number. Blue will be the multiplier. C is the multiplier. So blue over here is 10 to the power 6. The power 6. Okay. The value of the resistance is 23 10 to the power 6. Now silver. Silver is your tolerance. It will be plus minus 10% tolerant. Okay. This will be the value of your resistance. Okay. Now till now we have studied about from the color of the resistance, which is given in the resistance, how do we find the value. Now we will find the combination of resistance. What will be the value for combination of resistance? Okay, first one is, there will be 2 combinations. One is series combination and other one will be parallel combination. So I'll draw a simple diagram here. I'll take 3 resistors connected in series with a battery, which which has what potential? V. Okay? So the current flows from higher potential to lower potential. This is resistance 1, resistance 2, resistance 3. Now, this point will be this B, this C, and this D. Okay. Now the current I is flowing from the positive terminal and it passes through R1. The same charges will pass through R2 and R3. So the current throughout in a series combination will be same. So I is same throughout. Same throughout. Now potential V. If you take this to terminal, V will be V1. Between these two it will be V2 and between this it will be V3. But the total potential is provided by the battery, that is V. So V is equal to V1 plus V2 plus V3. To find the resistance, we will see what is our V1. V1 from ohms law, V1 is equal to I into R1. Current will be the same throughout, so I will write it as I. V2 will be I R2 and V3 will be I R3. So putting the values of V1, V2, V3 in this equation, let's see what we get. V is equal to I R1 plus I R2 plus I R3. Now our V is potential, that is I into R. I into R. This R is known as equivalent resistance or the total resistance in the circuit. Okay. Now from this law, if you take R common, if you take I common, inside the bracket you can write R1 plus R2 plus R3. I and I get cancelled. Equivalent resistance R is equal to R1 plus R2 plus R3. So whenever the resistance are connected in series, the total resistance will be R1 plus R2 plus R3. We have to add it accordingly. Okay, we have to simply add it. So the total resistance will be greater than the resistance which is there in the circuit, will be greater than the resistance. So if you want to find a higher resistance, if you want to develop a larger resistance using small values of resistors, then what we do is we connect them in series. Now we will do the derivation of series of combination of resistors in parallel. Now this is resistance 1, resistance 2,